So in this video, we're going to talk about graphing lines. So for example, let's say we're asked to graph the line y equals negative 1/2 x plus 3. So remember, when you graph a line, how many points do you need to graph a line? I talked about this in the previous video, I believe. So we talked about how we need 2 points to graph a line, right? In this equation, we're given some information. We're given the slope. Let me just write this down here. M equals negative 1/2. And we're given the second coordinate of our vertical intercept, right? 0, comma b, the vertical intercept. Actually, let me just write vertical intercept. Is the point 0, 3. Okay, so you can see that we have one of the points already that our line is going to go through. Okay, so how can we use the information that we have to get from this point 0, 3 to a second point on our line? So let me explain. Remember in the last video I talked about how the slope is the rise over the run. Now what does that mean? So remember the formula y2 minus y1 over x2 minus x1. The change in the y values, right, that's up and down. If you think about your y values as your vertical axis, you're moving up or down, or you're rising, right? You're going, I guess rise you would think of going up. But let's say you had a negative. So in our case we have negative 1/2. Now notice I can actually write this as negative 1 over 2 or 1 over negative 2. These are all the same, right? Negative 1/2 is the same thing as negative 1 divided by 2 or 1 divided by negative 2. If your numerator, if your rise is negative, right? Think about your vertical axis here. If your y values are negative, then you're going down, right? You're going into the negatives. If your y values are positive, and you're getting more and more positive, you're going to move up. So your rise is whether you're going up or down. And when you think about run, like if you're running on the ground, you're moving left or right, right? So if it's positive, you're going to move right, right? Positive axis, you're moving right. If your run is negative, then you're moving left. So your slope here tells you where to move from a point that you already know is on your line. So we said that our line goes through this point 0, 3. So here, negative 1/2, I said, is equal to negative 1 divided by 2. This tells me I'm going to move down 1 and to the right 2. Okay, so from this point, if I move down 1 and to the right 2, I end up at this point here. So now I have 2 points that I know my line has to go through, so I can connect those points, and I've graphed my line. Now notice what happens if I wrote this as 1 divided by negative 2 instead. So from this point, if I move up 1 and to the left 2, this is not to scale, by the way, but we're going to try to make this as accurate as possible. To the left 2. Notice you end up with 2 points on the same line that we drew earlier. Okay, so these are the same. Okay, so we've graphed our line here. This is y equals negative 1/2 x plus 3. So now let's look at another example. Let me erase this one. Let's say we want to graph the line that goes through the points 4, 3, and 1, 2. So these instructions say graph the line that goes through these 2 points here, 4, 3, and 1, 2. So now, and in earlier video, we actually found the equation of this line, and we had it in slope-intercept form. So you can take that equation that you already had and graph this with the same method that we did the previous example, example 1. But remember, what did we say we need to graph a line? Okay, we only need 2 points. And in this example, we're given 2 points. So this is actually fairly straightforward. We just plot these 2 points. There's the point 4, 3, and the point 1, 2 is here. And we can connect those 2 points with a line. And we're done. We have the graph of the line that goes through these 2 points. Okay, let's take a look at another example. Let me erase this. Let's say we have the equation 2/3 x equals, 2/3 x plus y equals 4. Plus 3y equals 4. Okay, we want to graph this line. So, of course, we could change this equation to slope-intercept form and use the slope and the vertical intercept to graph like we did in the first example. But we don't really have to do that. There's many ways to graph lines. Keep in mind, all we need is 2 points, right? So some easy points to find here. We can just plug in a value for x and find y, and that would give us a point. And an easy value to plug in is 0. So let's do that. Let's plug in 0 for x. And let's solve for y. 2/3 times 0, that's 0, plus 3y equals 4. So this is just 3y equals 4. Divide both sides by 3, we get y equals 4/3. So this is saying when x is 0, y is 4/3. So that means this line must go through the point 0, 4/3. Okay, so there's 1 point on our line. Now let's find a second point. Let's now plug in 0 for y and solve for x. Okay, let's solve for x. We get 2/3 x equals 4, because 3 times 0 is just 0. Let's multiply by the reciprocal of 2/3 to isolate x. Okay, the left-hand side, I said reciprocal of 2/3, not multiplied by 2/3. So we flip the fraction. Like this, okay, because these 3's will cancel, these 2's will cancel, and we'll just get x on the left side. And here we have 2 goes into 4 twice. 2 times 3 is 6. So x equals 6 when y equals 0. So that means our line must go through the point 6, 0, right? X is our input and y is our output. Okay, so now we have 2 points on the line, and we can graph these 2 points. I want to make a note though, it's not important that I plugged in 0. You can literally plug in any value you want for x and solve for y, and plug in any value you want for y and solve for x, and you'll get the 2 points that you need. Okay, so let's graph these. We're going to plot our 2 points. Zero 4/3. So 0 4/3. 4/3 is what? I don't know. Let's turn that into a mixed fraction. Let's divide. Okay, 4/3 is equal to 1 1/3. So that's about here. So there's the point 0 4/3. And now 6, 0, 1, 2, 3, 4, 5, 6. And now if I connect those 2 dots, with a straight line. There's the graph that I'm looking for. Pretend it's straight.